So as you can see, we're starting with Chapter 6 today, and as I mentioned, we're starting with Chapter 6.4 instead of Chapter 6.1, and that's because we're just going to jump right in the middle, and we're going to be just fine, okay? And so this lesson is about factors, and your learning goal today is to be able to express a whole number as a product of its prime factors. Now, there's a lot in that learning goal, right? We need to know what a whole number is. What's a whole number? Siddharth?
A number that's not a fraction or like a decimal.
Yeah, a number that's not a fraction or a decimal. And we have to express it as a product. So when we're talking about products, what does that mean we're talking about? Adriana?
Isn't it multiplication?
Yeah, so we're going to be dealing with multiplication, and we're going to be dealing with prime factors. And in order to know what prime factors are, we have to think about what prime numbers are. And we're going to talk about that a little bit more today. But let's first talk about the problem of the day. It says, a construction worker is installing an underground pipe. He can install a 1-yard section of pipe in 10 minutes. How many feet of pipe can he install in 2 hours? So the first thing we want to write down is a vocabulary word. We definitely want to write it down. We want to write down that a factor is numbers that are multiplied to form a product. So here you see a multiplication sentence, 2 times 3 equals 6. Which numbers are the factors, Marcus?
They're the numbers that you can put together to make a number.
They're the numbers you multiply. So in this multiplication sentence, 2 times 3 equals 6. Which numbers are the factors?
2 and 3.
2 and 3 are the factors. And what number is the product? 6. The answer is the product. So I have a challenge for you. In your notebook, can you write down all the factors of 12, all the numbers that you can multiply together to equal 12? What are the factors of 12? Go ahead and write them all down in your notebook. A prime factor is a whole number a prime number is a whole number greater than 1 that has exactly 2 factors, only one and itself. Okay, so a prime number is a number that only has exactly 2 factors. Can a prime number have only 1 factor?
No.
No. Can a prime number have 3 factors?
No.
A prime number needs to have exactly 2 factors. I want you to, in your notebook, after you write down the definition, see if you can challenge yourself to write down some prime numbers. What are some prime numbers that you know? A composite number is a whole number greater than 1 that has more than 2 factors. Can a composite number have 3 factors?
Yes.
Can a composite number have 1 factor?
No.
2 factors? 5 factors?
Yes.
Okay. A composite number can always be written as a product of its prime factors. Now I'd like to challenge yourself to write down some examples of some composite numbers in your notebook. Okay, so we can do 10 times 2. Those are 2 factors of 20. Then we need to check in with the factors. Is 2 a prime number?
No. Yeah. Yes.
How do you know 2 is a prime number? Siddharth?
It only has 2 factors, which are 1 and 3.
Okay, so if 2 is a prime number, we're going to circle it. Every time we find a prime factor, we're going to circle it. Marcus, go ahead and circle it. Is 10 a prime number?
No.
No, because it has more than 2 factors. That means we can continue to break it down into more prime factors. What are 2 numbers that multiply to equal 10? Daniel? 2 times 5. Okay, now let's check in with these factors and see if they're prime numbers. Is 2 a prime number?
Yes.
Okay, that means we have to do what to it? Circle it. Is 5 a prime number? So that means we have to? When all of your factors at the bottom of your tree branches are circled, that means that they are all prime numbers. Therefore, we can say that the prime factors of 20 are 2 times 2 times 5. And then this is how you would write out your answer in a multiplication sentence. In this problem, it says, Dion has forgotten the code for her locker. When you go to middle school and high school, you'll have a locker with combination codes where you have to turn the lock to unlock your locker, okay? She remembers that the 4 one-digit numbers in this code show 36 written as a product of its prime factors. What are the numbers in Dion's code? Okay, so again, we have a word problem. So what is the question asking us to find? What is the question asking us to find? Ariel? Yeah, we have to figure out what numbers are in Dion's locker combo. And what is the important information we need in order to solve this problem? Adriana?
Well, we need to know that she remembers that 4 one-digit numbers.
Okay, they're going to be one-digit numbers.
And also that 20 36
Uh-huh.
is written as a product.
It's going to be the prime factors of the number 36. So let's make another factor tree. We're trying to find the prime factors of what number, Claire? 36. Let's write that at the top of our factor tree. And let's get ready to write two branches. What are two factors that could multiply to equal 36? Rashika?
9 and 4.
Okay, 9 times 4. Now, let's check in with the factors now. Is 9 a prime number?
No.
No, so we can further break that down. What are two factors that could equal 9? Adam?
3 times 3.
Okay. Now let's check in with those factors. Is 3 a prime number? So we need to do what to it? Circle it. Is 3 a prime number? Let's circle it. Okay, let's make sure now. Let's see if all the factors at the bottoms of our branches are circled. Is this one circled? Good. That means it's a prime number and we can leave it. Is this one circled? Good. It's a prime number and we can leave it. Is this one circled? Why is it not circled? Sarah?
Because it's a composite number.
It's a composite number and not a prime number. That means that we can further break it down. Let's draw two more branches. What are two factors that could multiply to equal 4? Joseph? 2 times 2. Okay. Now let's check in. Is 2 a prime number?
Yeah.
We can circle it. Is 2 a prime number? We can circle it. Now let's check in. Are all our branches at the bottom, are they all circled?
Yes.
That means that we've broken everything down to its prime number form, and we can write out our answer. How would we write out the prime factors of 36? Arushi?
3 times 3 times 2 times 2.
Right, because we just multiply all the prime factors, and all of those multiplied together will equal 36. So, what is Dion's locker code? It must be 3322, or 2233, or 3232. Very good.